In this video, we're going to look at another logic problem. Such problems, we use a technique of making assumptions and try to derive contradictions, or if no contradictions appear, then the assumption is correct and we potentially arrive at a solution. So let's look at a problem. Grandmasters A, B, C, D, E competed in a chess tournament. During the tournament, 4 observers predicted the outcome. Observer 1 said E will be third, A fourth. Observer 2 said A will finish at third, B first. B is very strong. Observer 3 said B will be fourth. Definitely observer 3 is not very impressed by B. And E will be second. Observer 4 said D is my strongest player. D will be first, C third. It turned out every observer got half of his predict right. Now the question is, if there's no ties in the ranking, what is C's place? What's C's ranking among those 5 grandmasters? For these kind of questions, it's very useful to using this technique of making assumptions and derive from there. And again, it's very useful to keep a table about the actual true ranking. So in here, let's make a table. Ranking 1, 2, 3, 4, 5. And we have 5 players, A, B, C, D, E. Again, it really does not really matter start with which observer. Sometimes it actually turns out to be simpler if you're assuming from one observer to make the assumptions. But let's just using observer 1. Okay? So we're going to assume that in observer 1, in his statement, observer 1, there are 2 parts of the statement. E will be third, A is fourth. And we know that every observer, including observer 1, got half of his predict right. So there are only 2 cases. One is the first case, E will be third is correct. E is third. And A is not fourth. Case 2 is A is fourth is correct. And E is not third. Right? So let's look at case 1. E is third, so third is E. Let's make in here. The third one, okay, let's make a row here. It'll be much clearer. Okay, I'm not going to have the columns. It's not necessary. The column spaces are big enough. Okay, so E is third. Now, if E is third is correct, for observer 2, A will be third, cannot be right anymore. A cannot be third. So B has to be first. That part of his predict must be right because everyone got half of the predict right. So B is first. Now for observer 3, B will be fourth, cannot be correct because we just said B is first. So E is second. You see, we have a contradiction. Just from observer 1, 2, 3, if you assume E is third, you actually also arrive E is second. So this assumption cannot be right. So we have to have the second case. And we're going to do the second case. But here, let's clean up the table because the first assumption is not right. So let me clean out the table. Oh, unfortunately, all the rows are gone as well. But that's okay. We start with a clean table. So we said that the first case is wrong. So that means A is fourth. Let's put A is fourth, and E is not third. And from observer 2, A will be third. This is incorrect, so B must be first. And observer 3, B will be fourth. It's not correct. E has to be second. In here, C will be third. Do we have anyone third? No. But D will be first cannot be wrong, cannot be right, because we already have observer 2, B is first. So D will not be first. That means C will be third. And from that, even though we did not say anything about D, D only can be 5. Okay, so the ordering of this tournament is B, E, C, A, and D. And what's C's place? C is at third. And that is for this problem. To recap a little bit, again, have a table, keep track of the statements being wrong or correct is very important. And you can see contradictions very easily from a table. Hopefully, this table of true and false can be your powerful weapon.